morning, students. I hope all of you are fine today. So let's continue with the chapter which we have started in our online classes, that is the magnetic effects of electric current, students. Students, in our previous class, we have learnt about the magnetism, we have learnt about the properties of magnets, and we have also learnt about the magnetic field. Okay, students, now as we have learned in our previous class that if an electric current flows through a conductor, then it produces a magnetic field. Now, one question arises, that is, what will be the direction of the magnetic field if the current flows through a straight conductor, if a current flows through a straight wire? So, for this reason, we are doing an activity, okay, which is the magnetic field due to a current carrying conductor. So what we have to do, students, let's have a look. I have taken one straight, or I have taken a long copper wire in which I have connected one switch, and I have taken a battery which is made up of 3 cells. Each cell consists of 1.5 volt. Okay. Now after that, I have placed a long straight wire, okay, between these two terminals. See, I have placed one straight wire between these two terminals. Alright, now after that, I have taken one magnetic compass and I have placed parallel and above this straight wire. Okay, I have placed the magnetic compass parallel and above the straight wire. Now what I have done, students, I have just switched on the key. Now the current will flows from this direction. Okay, see, the current will start flowing from here to here, that is, and it will flows through north to south. That is, we know the direction. This will be the north, this will be the south, this will be the east, and this will be the west. So the current is flowing from north to south, from this to this. Okay, so now students, as the current is flowing from north to south, so the magnetic compass will show a deflection. So in which direction the needle will shift? So this will be the needle, okay? So the magnetic compass needle will shift to here. That is, it will shift in the east direction. It will shift in the east direction, students. So just remember this, that if the current flows from north to south, then the magnetic compass needle will shift to east direction. Okay? Alright? So remember this, if the current flows from north to south, then the deflection will be towards east. Okay? Now, what I am doing here, I am just changing the setup. Okay? So what I am doing now, I am just erasing this battery, okay, and I'm connecting the battery in the reverse direction like this. See, so the direction of the current flowing in this wire will be also changed, correct? So what will be the direction of the current? So the current will flows from here. Okay, so the current will flows from here, students. See, the current will flows from here. Alright, so that is, the current is flowing from south to north, students. So the current is flowing from south to north. That is, I have just reversed the direction of the current flowing through the conductor. Now, as the direction of the current flowing through the conductor is changed, so the deflection will also be changed. So what will be the deflection now? So the deflection will be in the reverse position. That means it will shift, or the needle will shift in the west direction, students. See? So the needle will shift in the west direction. Alright? So if you just reverse the direction of the current from south to north, then the deflection will be towards the west direction, students. Okay? So from this activity, we just come to know that if a current flows from north to south, then the deflection will be towards the east, okay? And if the current flows from south to north, then the deflection will be towards the west, students, okay? So this is how we have got the direction of the magnetic field through a current carrying conductor. Okay, students, so this is a very important topic. You have to remember this. So go through this topic, okay, and read the activity carefully, and you will get to know about this topic again. All right, students, so that's all for today, students. Thank you.